Hello and welcome to yet another episode of Revit MEP by BIM Technologies. So in this episode we are going to learn about how to create layouts of duct from the existing equipment and air terminal. In order to show how the layout can be created automatically from the existing air terminals and the equipments, we have an example over here. So here in this model we have got some air terminals which are supply air terminals. So if you select the air terminal, you would see that the air terminal type is supply diffuser and they are at a height of 2400 from the level 0. Level 0 is the level from which the reference is made, the lowest level. And apart from this, the flow of this particular air terminal is 150 liter per second, and as such all the air flow that has been assigned to the air terminals are 150 liter per second. And then we have got some FCUs, that is a fan coil unit. So you can see that 1, 2, 3, 4 fan coil units are there to serve the VAV over here. So we have a VAV, which is a VAV unit parallel fan, which is having a 300 mm inlet, which is size 2 over here. And we have air terminals which are supply air terminals. So we have got two types of equipment and we have got this air terminals over here. So we have got 1, 2, 3, 4, 5 rows of air terminals with 1, 2, 3, 4, 5 columns. The total 20 air terminals are there, and we are supposed to do a duct layout of this particular project. So in the 3D view you can see that the air terminals can be seen in the space. Now we are at the 0 mech floor plan, which is the lowest level, the floor plan of the lowest level. We at the HVAC subdiscipline of mechanical subdiscipline. So we created this model by using the mechanical template. So we have only one discipline, two disciplines, that is the mechanical and plumbing, and the corresponding plans and the elevations and 3D views are displayed for the disciplines. So the first row has 5 air terminals. So we select, you are using the control key, all the 5 air terminals. So when we select the 5 air terminals, we can also select the VAV to which we want to create. But let's see, we select how the duct is created. So there is, you have this modify air terminal and there is an option called create systems. So here we can choose the duct tool over here, and it says create, the create systems dialog box is displayed. Now the system type is supply air, and the system name we can specify the name of the system that comprises of the 5 ducts can be specified as S supply air 1 and choose OK. The moment we create this system, a bounding boxes can be seen, and the properties palette, the properties of the duct system supply air is displayed over here. You can see the SA1 and the total flow, and the flow of each of the air terminals is 150 liters per second. And with this, in the contextual tab you can see the modified duct system contextual tab is displayed and various options are seen over here. And one of the options in the layout is a generate layout. So I can choose a generate layout over here. The moment I choose a generate layout, I can see that there is a layout which is displayed over here, and then here at this generate layout panel you can see there are various tools which is displayed. We have the solutions, we have this edit layout, and different options are there. Now in order to see the different solution types that we have, so we can see there are 3 options are there in this drop down list. So I'm going with the 3D view here, and I can see that the green lines and the blue lines are displayed. So let's go to the settings first, and in the settings we can select type of duct that I want to use for the main, which is the blue line. I can add the height of, let's say, 3200. It's the mid elevation of the duct, and for the branch also we can take 3200, and the duct type we can select the same as radius duct, flanged radius bend one. So with this, now when you select this particular options, now you can change the layouts over here. So I've got a layout over here which says that this is the option that can be created. Here I can increase the height of the branch and the main, and then when I finish it, a layout, rigid layout will be created, and I can see that in some of the ducts over here the flex duct is created. Now in order to correct this one, so what we can do is, in the 3D view, just we can delete the flex ducts and the you can see there's a duct fitting over here, so I'm going to delete this one, right? And from here, if I want to, and also these terminals, so I want them to get connected with the duct. So this is a one of the mechanism that we can apply here. So what we do is, in order to create correct layout, we have to do some modification. That's what I'm doing. So I'm deleting this fittings and only keeping the air terminal. So one, the last one I have, and here we go. And there is one connection, the solution is not provided. So what I can do is, here in the top view, so here we can see there are certain disconnects that has been done. So what we can do is, we can connect them in the 3D view itself. So what we can do is, we can directly click on the control point over here, drag it perpendicularly and join them with the duct. So now you have got one straight duct here, and if you want to connect this particular air terminal with the duct, select it, and then under the modify air terminal you have got the option called connect into. Choose that, and you can see that the duct is getting connected. Similarly, drag this control point and bring it towards the next duct over here, so that a connection, a continuous connection is created. Delete the fittings that you have created earlier and click on the connect into option here. So you get this air terminals connected with the rigid duct, and moreover, if you want to connect this, generate, and you can go for connect into option. Select this, and then you can go with the connect into option. So you have got this duct which is created, and here what we need to see, that we have to see the VAV has to get connected with the duct. So what we can do is, we can connect into option, select the supply air rectangular 350 into 280 flow direction out, and select this duct. So you can see that there is a connection which is created along with the duct over here. And similarly, if we want to, we see that there is a round duct here, and there is another connector over here. In order to see what type of connector it is, we can go to the family, select it, go to the edit family of the duct, and from here we can see that it is, what is the, so here we have this at the top, this is the electrical connector, and let me see the connectors over here. So there is a connector here which is the rectangular, and this is for the return air. This is for the, this connector is for the supply air. So you have got the connector which is at the right in face is the for the supply air, and this connector is for the round for the supply air. So this is in. So what I can do is, I can select it towards the So this particular connector can connect into the, so if I want to connect this, so if I want to connect this, so I first of all, this is the FCU which is supplying, the main branch is going from the FCU and it is supplying it to the VAB. So what I can do is, here in the mechanical plan, I can first of all see where my supply output is. So this is, here we have, so the duct, so you can see that if you draw a duct, it will take the middle elevation, so this can be one of the routing option, and then you can bring it vertically here. So the elevation over here is, the mid elevation you can check is by default is 3454, and from here, let's say if you have this duct here, so you can get the round duct from here, and this is the, then you can somehow connect. So this is, the connection can be, and the position can be made. So what we can do is, instead of getting the, we have to set the position of the round duct, so bring it in parallel with the FCU. So you have this round duct here, you can bring it in parallel with the FCU and try to connect this particular, drag it here and get it connected with, so it says there is no room over here, so we have to see. So these are the type of so what we can do, if we select it and see, we have a connect to option, we can select this duct. So this is the round chilled water flowing direction out, so we can have this supply air. So this particular would be the connector, and we are going to connect with this particular duct. So what we need to do is, in order to connect this, we have to have proper angle for the connection. So we can see connect into, because it is, again take a rectangular and then you can select it, and you would see that somehow there is a geometrical. So in order to solve this situation, what we can do is, we have to check the height of this. So let's say we bring it here, and as in parallel to it, we have to see what is the height of this particular. So it says 3200, and this is basically 34, this is also 3200. So we can move this above. Let's say we move this 4 meters so that it has got enough space, or let's say here in the 3D view we can adjust the heights. So here we go and see if we can adjust the height. We can go with the 4 meters. So somehow when you are creating this kind of geometries where you are going to connect one system to the other, you need to check out the geometrical limitations of each one of them, because here you can see that there is a duct which is rectangular duct, and it has to fit along with this particular round duct where a conversion has to be done. So this middle elevation here is something that you need to look forward for, and then what you can do is, you can bring this here, or let's say you can go to the ceiling plan and look into it, or into 3D view, or in the 3D view, because this is something that you can bring it down. Let's say bring it 3500 here, and in the plan view it will be visible here. So what you can do is, you can bring this duct to a part which is in parallel to this one, and then try to draw another duct which is, and then you can connect these two elements together so that they become, so you can see here there are two different sizes here. So I can convert this particular size at this moment of time to a round duct. So I can select this, I can make it a round duct here where the conversion can be made. So let's say I create a round duct here, and then I can connect this with a So we will be requiring a transition here. So you can see that now this particular duct is connected with the air FCU over here. So one thing can be done is, in order to create the elevation difference, because there can be pressure losses, we can bring it to the same height, let's say 3200, and see what. So if the duct will not move, so we have to, let's say, what is the best elevation that we can move into it. So 3500 may be the best elevation by which this can be created. So you can try with different values. Now if you look into it, the system is now created with a VAV duct, and similarly this is the main branch which is going, and it is connecting, and whatever you see over here is the flow lines over here. So you can check the supply and the other flow lines over here. So if you select this air terminal, now you would see that there will be a flow which will be created. So what you can do is, so select this one, air terminal 1 2 3. So there is a system which is created over here. So this is an SA1, and similarly if you select this, you can see that there is a system which is created. And then you can go with the system inspector here, which will be showing you for there are two supply air system. You can go with the SA1 and mechanical supply air, because this is the one supply air system which is created for the entire portion of the building. Probably it may basically give air or supply air for more VAVs. So here if you want to inspect for SA1, you can see that there is a flow line which is created, so you can inspect it, and there would be a static pressure and pressure losses over here. So this is the VAV duct over here, and it is having a static pressure and a flow of 750. Similarly from this particular branch line, if you want to, and similarly if you want to finish it, you can finish it. Now the next part is sizing the duct. So you can have this kind of arrangements over here. Let's say if I want to create a duct from the elevation here itself from the main branch, and I want to connect this to the main branch, so I can click on it and I can connect this directly to the air terminals over here. So this is directly connected to the main branch. So here you can see that how the connection is done, and it is done through a round duct, and the tap is over here. So this is some and then other things that you can do over here is you can size the ducts, right? And also you can create similar routing or layouts for the other ducts and have the VAV or the FCU work for it. At last, I'm going to finish this video with the duct sizing, and other thing is that you can also go with the color schemes. So if you go to the analyze, there would be an option where you can create color fills and duct legends. So you have a duct legend, and in the duct legend you can have click over here, and you can click on the velocity. So you can see that it will be showing different velocity in colors for the different ducts that is shown over here. Similarly, you can edit the scheme, and you can have it for, let's say, sizes of the duct, and let's say if I want to go with the flow, and I can create different schemes. So this is the flow. So here you can see that the flow is 300 liters per second, and they're changing its color over here. Now if you want to size the duct, you can press the tab key, select the system over here, then you have a duct pipe sizing. So there are different methods. You have a friction method, velocity method, equal friction, and static region. So if I take the friction method over here, so I have to enter the friction at which I want to design, and the sizing, it's only for the for the ducts. And if you want to restrict height, so branch sizing is for the size only. Choose OK, and you can see the sizing would be done, and some warning messages will be coming in order for the mechanism to be, so after the duct sizing is done, the system is now balanced. So well, hopefully you have enjoyed this video. In the next video we will be learning about the plumbing system. Don't forget to like and subscribe our channel of BIM Technologies. Thank you.